Hi everyone, I'm Elliott. I'm very happy to share our research with you. The title is VRhook, a data collection tool for VR motion cynics research. VR gaming has been gaining widespread popularity in recent years. However, according to previous research, up to 40% of users still suffer from VR motion cynics. The eye fatigue, nausea, and disorientations are among the most common symptoms. They can negatively impact the VR user experience. Many research results suggest that VR content is the most influential factor for VR cynics. Potential factors include fast-moving speed, excessive rotation, wide field of view, and inappropriate depth of view. Recently, researchers have attempted machine learning approaches to identify the presence of motion cynics content factors in VR games. Despite the progress made, many of these studies point out that their models are constrained by the size of training dataset. To improve the model generalization, we need to acquire larger datasets containing many thousands of video clips of VR gameplay and the corresponding risk factors. Unfortunately, conventional data acquisition strategy cannot meet this requirement. Firstly, manual annotation by human expert is very expensive and does not scale with the number of games. Secondly, building custom-made VR games for data collections wouldn't generalize the generalizability issue. Finally, modify existing VR games to extract the data would require some source code access, which is practically impossible due to the proprietary natures of most VR games. To overcome these challenges, we present a novel data collection tool named VRhook. VRhook can automatically extract labeled data from a wide range of real-world VR games without accessing their source codes. A core mechanism for our tool is dynamic hooking, where we inject custom codes into runtime memory to intercept low-level graphic pipeline data. In particular, we are interested in video frames and transform metrics, which can be used to extract video clips and many useful ground truth labels. Here's a quick demo of our tool.
To use our tool, we start our VR game as usual. Afterward, start our capturing tool. The tool will automatically locate the gaming process and intercept useful data from it. The data include eye buffer frames, 3D scene translation, rotation, headset and joystick movement, luminance, field of view, depth information, etc.
Our tool intercept data in two levels. The first one is GPU level interception. We place hook on low-level graphic API stacks, including DirectX and OpenVR. They are highly standardized and remain almost the same regardless of the games being run and machine being used. As a result, our tool can place hooks on almost the same memory addresses in this stack to extract data from many real-world VR games. To acquire the transformation matrix, our tools can intercept constant buffer submitted to vertex shader. To obtain the video frame, our tools can intercept the swap chains to obtain the back buffer. The second level is engine level interception. The idea is that almost every VR game is built atop Unity and Unreal Engine. These engines have very standard internal rendering pipeline where we can place hooking function. Compared with the GPU level interceptions, these allow us to capture more semantic data, such as object names and light source location, etc. VRhook can capture two types of data. The first one is VR scene data, which is automatic data. It includes RGB images, camera setting, object data, depth buffer, optical flow, and user joystick input. In addition, our tools can also capture use self-report. And we achieve this by displaying an in-game slider overlay on any VR game. This allows us to incorporate a previously validated dial mechanism to collect self-reported comfort score from users. To show the utility of VRhook, we build a proof of concept machine learning pipeline. Given a gameplay video, we feed it into a slow fast model to detect the presence of factors that might contribute more to motion cynics. and these factors are further fed into a support vector machine to predict the comfort score. Our results show that the pipeline achieved decent performance, and the performance can be further improved by feeding more training data and do some parameter fine-tuning. Recently, we are collecting more data from all of the show VR games from different genres. We aim to make a dataset contribution which is similar to ImageNet, but in the context of VR motion sickness research. If you are interested in this dataset, you can contact us at this email to acquire the dataset. Thanks for your time. I'm happy to answer any questions.